In this video, we're going to do some business application problems. The first problem says a company that manufactures bicycles has costs given by the equation below, in which X is the number of bicycles manufactured and C is the cost to manufacture each bicycle. So here's our formula. First, we want to find the cost per bicycle when manufacturing 500 bicycles. So what I'm going to do is plug in 500 for X. So this is going to be 100 times 500 plus 90,000 divided by 500. Now I could type this entire thing into the Desmos scientific calculator. I could also do it by hand. I'll do that just to show. When we multiply 100 and 500, we get 50,000. 50,000 plus 90,000 is 140,000. And 140,000 divided by 500 is 280. So the cost per bicycle, if I make 500 bicycles, is $280. And that includes the variable costs. So $100 of the 280 is the cost for parts, labor, etc. for that particular bike, and also includes the share of the fixed costs. So this $90,000 is split up over 500 bicycles. Each bicycle needs to take on $180 of the fixed costs. Question 6 says how many bicycles need to be made so that the average cost per bicycle is $118. So now I'm going to put 118 into the equation for C and solve the equation for X. So 118 equals 100x plus 90,000 divided by x. Now to solve this equation for x, first I'm going to multiply both sides of the equation by x, and that's going to get rid of the x in the denominator. So my equation is now 118x equals 100x plus 90,000. Now that I've gotten rid of the fraction, I'm just going to get x by itself. So we'll start with combining the x's by subtracting 100x from both sides. And that's going to give me 18x equals 90,000. And the last thing left to do here is divide both sides by 18. And 90,000 divided by 18, use a calculator, and you will get 5,000. So if I make 5,000 bicycles, I will lower my average cost per bicycle to $118. So the idea here is that the more bicycles that you make, if I go from 500 bicycles to 5,000 bicycles, my average cost per bicycle is going to be less. Now you have to sell all those bicycles, which is a whole another problem for the business, but I'm spreading my fixed costs over more bicycles. That means that the average cost per bicycle is lower. Finally, we're going to look at question 7. A government agency ordered computer-related companies to contribute to a pool of money to clean up underground water supplies. The companies had stored toxic chemicals in leaking underground containers. So we have a formula that models the cost in millions of dollars for removing X% of the contaminants. What percent of the contaminants can be removed for $390 million? So with this cleaning up problem, we have a situation where it's relatively easy to clean up a little bit of the contaminants, but if we want to be more precise and clean up most of the contaminants or all of the contaminants, that's going to get a lot more expensive. So we want to find what percent of the contaminants can be removed for 390 million. X is the percent, so that's what we're solving for. 390 is going to be plugged in for the cost, which is already in millions of dollars, so we don't need to worry about the million. We're just going to plug in 390. So we have 390 equals 360x divided by 100 minus x. And this is the equation that we need to solve. So in order to get rid of the fraction here, I'm going to multiply both sides by 100 minus x. And I'm putting it in parentheses because I need to distribute on this side. So 390 times 100 minus x equals 360x. Now I'm going to distribute this 390. So that's going to give me 39,000 minus 390x equals 360x. Next, I'm going to combine the x's by adding 390x to both sides. So we have 39,000 on the left side. When we add these together, we get 750x on the right. And lastly, I need to divide. So divide both sides by 750. Use a calculator, and I'm going to get x equals 52. So 52% of the contaminants can be removed for $390 million.